Okay, so the lecture for today we will be talking about ChiSquared. So it's pronounced ChiSquared. And we're going to be conceptualizing goodness of fit ChiSquared and test of independence ChiSquared. So we're going to be discussing two different types of ChiSquared tests. So in this, you should understand the conceptualization of ChiSquared, meaning when it's used, and you should understand an example, and you'll see an example in this lecture of each. So let's quickly recap the statistical tests that we've gone over, or the most recent ones that we've gone over. So we have t-tests. T-tests compare means of two samples. And t-tests indicate whether there's the difference in these samples or the difference in means between two samples is due to a sampling error or an independent variable. So in essence, it examines the influence of one independent variable with two categories, so for example Democrats versus Republicans, on a continuous dependent variable. So the like versus dislike of Barack Obama on a 10-point Likert scale, for example. So in this case we have an IV that has two categories, right? So an independent variable with two categories, and we have a dependent variable with that's on a continuous scale. So this is categorical IV, continuous DV. One-way ANOVA compares means of two or more groups and indicates whether differences are due to measurement error, individual differences, or an independent variable or group effect. And so in this case, it examines the influence of one or more independent variables with two or more categories, right? With one independent variable with two or more categories. So it's just one independent variable. So an example here would be Democrats versus Republicans versus independents. That's our independent variable. And we're looking at how that would influence people's perceptions of the like versus dislike of Barack Obama on a 10-point continuous dependent variable Likert scale. Right? So in this case, it's one independent variable with two or more categories as it influences an outcome variable or dependent variable that's on a continuous scale. Twoway ANOVA adds a little more complexity. So Twoway ANOVA compares means of two or more samples or two or more variables across multiple independent variables. So this indicates if differences are due to measurement error, individual differences, or an independent variable or group effect. And so in this case, it examines the influence of two or more independent variables with two or more categories each. So for example, the influence of independent variable 1, Democrats versus Republicans versus independents, and independent variable 2, voting for Obama versus not voting for Obama, on a continuous dependent variable, the like of Barack Obama, right? So in this case, again, we have two or more categorical independent variables as they influence one continuous dependent variable. And additionally, it examines the interaction of the two independent variables, right? The way that the two independent variables work together to create a type of outcome. So let's look at ChiSquared. Let's take an overview of ChiSquared. So ChiSquared is similar to what we've seen before, but there's some significant differences here. So what ChiSquared does is it analyzes data across categories. So while the previous statistical tests we've been looking at have been looking at the means and the difference in means, the ChiSquared looks at the difference in frequencies, or the relative difference in frequencies across groups. So in these cases, we're using categorical data, and most specifically, we're using nominal or ordinal data to look at the frequency counts of categories. And what I mean by frequency counts is the number of people who fall into various categories. So there's two types. There's the goodness of fit ChiSquared, and this examines the difference in frequency of group membership across one categorical variable. Then there's also the ChiSquared test of independence, and this examines where the frequencies of one variable are related to the frequencies or the categories of another variable. So in both cases, it's the variables in these cases are categorical only. We do not look at continuous variables in this instance. So the logic here is, what we're doing is we're analyzing the observed frequency of a group versus the expected frequency of a group. The big limitation here is if the expected frequencies are less than 5 per category, a chi-squared should not be conducted. So this happens in a case when you have a small sample size, right, or a small n, and a lot of categories. If you have a lot of categories with regard to your sample size, then you are going to have frequencies that are less than 5 per category, and you shouldn't conduct a chi-squared analysis. So let's use an example. So say we're interested in the frequency of Democrats, Republicans, and Independents currently in BIS 315. So our variable here is political affiliation, and political affiliation is categorical, or in this case nominal, right? So political affiliation is Democrats, Republicans, and Independents. And so let's just take a frequency here, right? So say we have 11 Democrats, 11 Republicans, and 10 Independents. So 11 of you guys are Democrats, 11 are Republicans, and 10 are Independents. So in this case, we would be using a goodness of fit chi-squared. And this would help us answer the question, is there a significant difference in the number of people in each group? Right? So do these groups significantly vary from one another? Are there significantly more or less people in various categories? Let's take an additional example. Is political affiliation related to whether or not someone voted for Barack Obama? Right? So we have two variables here. And so we can break this down and expand it a little bit, right? So we have the same categories, Democrats, Republicans, and Independents, but then we split it up into one more case, where we have voted for Obama, did not vote for Obama, right? And so what we're looking at is, we're asking the question, is there a relationship between these two variables? So, we have some Democrats who voted for Obama, some Republicans who voted for Obama, some Independents. We also have fewer Democrats who voted for Obama, even fewer, a lot more Republicans who did not vote for Obama, and about the same number of Independents. So in this case, a chi-square test of independence is what we would use, because we're asking the question, is there a significant difference in the number of people in each group? And is there a relationship between the two variables, right? Is there a relationship between being a Democrat and voting for Obama, or being a Republican and not voting for Obama? And that's the question we're trying to answer. So let's give an additional example here. So say I'm interested in knowing whether there's a difference in the class year, where class year is split into freshman, sophomore, junior, and senior, of my students, of you guys, of BIS 315. What chi-squared test would be used for this question? Well, this would be a goodness of fit test, because we're just looking at one variable, right? We're looking at class year as a variable. Additionally, I'm interested in examining whether class year, measured as the same as above, is related to whether or not students will score greater than 3.0 in my class. And so, this case, we've added another variable, class score, measured by 3.0 and above versus 2.99 and below. So this, we would use a test of independence, because we're trying to examine the relationship between the two variables, right? Between class year and between grade. So your learning goals for this, you should understand what chi-square goodness of fit does, what it examines, and in this case it examines the difference in frequency of group membership in one categorical variable. Chi-square test of independence, on the other hand, examines whether the frequencies of one variable is related to the categories of another variable, or the frequencies of another variable.